Let's get ready for fun time. This is Mr. Bryce with Susquehanna Valley High School here in Concord, New York. We're doing Common Core Algebra 2 non-Regents version. We're going to be talking about average rate of change. If you don't understand what I'm saying, just scan that QR code and listen to the genius that wrote these worksheets. Okay, we know average rate of change. That sounds like, what is rate of change? Rate of change is delta y over delta x. Slope. So average rate of change, let's see what we're doing. When we model using functions, we're very often interested in the rate that the output is changing compared to the rate of the input. The function f of x is shown graphed to the right. Cool, there it is. Evaluate each of the following based on the graph. What is the function value at 0? 1. What is the function value at 4? 1, 2, 3, 4. Up 1, up 2, up 3, up 4, up 5, up 6, up 7. 7. What's the function value at 7? 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last one is 11. Okay, that seems fairly nice. Find the change in the function delta f, delta change over each of the following domain intervals. Find both by subtraction and shown on the graph. Okay. From function value 0, actually, we're not going to do that. We're going to do the second one minus the first one. Okay, or we can take the absolute value of it. Second minus first, 7 minus 1 is 6. F of 7 minus f of 4, that's 10 minus 7, which is 3. F of 13 minus f of 7, 11 minus 10, which is 1. Why can't you simply compare the changes in the function, delta f, from part B to determine over which interval the function changes the fastest? Changes the what? Changes the fastest. We're not saying changes the most. We're saying which one changes the fastest. Speedy Gonzales. Okay, that's a cartoon character. Which one changes the fastest? See, he was the fastest cartoon character. Well, maybe Flash was, but I don't know. We can debate that. Why can't we? Let me see. This has a gap of 4 in the x. This has a gap of 3 in the x. This is a gap of 5 in the x. The delta x is not the same. Oh. Calculate the average rate of change, for the function over the intervals timetable. Okay, so we do average rate of change. Delta y over delta x. Delta y over delta x. Yes, you got to write it down again. Delta y, right there, 6. Right where? Right there. Over 4 minus 0, which is 6 over 4. Delta y over delta x. It's 3 over 7 minus 4. Simplifies to be 1. Delta y over delta x. 1 over 13 minus 7, which is 1 over 5. Okay. Let's see. This one, that one appears 1.5, appears to be the fastest, appears to be the greatest. Does it look like the greatest on the graph? Whoop. That's fairly steep. that's steep too, but that's not. Okay, so that appears to be the steepest. Using the straight edge, draw the lines of the slopes you found in Part D by connecting the points shown on the graph. The average rate change is a measure of what property of the line? Wonder what Mr. Bryce said earlier. Okay, so I am going to take a straight edge, go from there to there. Let's see, can I take a different color? Go from there to there. So I corrected a mistake here because I drew the dotted line. That's 15 minus 10, which is 5. So coming back down here, it's 5 over 5, which is 1. Constantly think about your work. Say we did that by connecting the points to the graph. The average rate change gives a measurement of what property of a line? It's slope between 2 points. That's what average rate change is. Slope between 2 points, not the slope of the curve at any one given time. The slope between 2 points. Next page. The average rate change is exceptionally important in the concept of mathematics because it gives us a way to quantify how fast something is changing over a certain domain interval. This is so important. I mean, you're talking about it in physics, you're talking about it in economics, when we talk about the economy, okay? When you're talking about the stock market, there are things that are technical analysts use graphs. Okay, so when you're talking about the average rate change, that's just the basic beginning of getting into the stock market. For a function over the domain A is less than or equal to x, which is less than or equal to b, the function's average rate change is calculated by, okay, remember f of x is the same thing as y. So that's delta y over delta x. That's y2 minus y1 over x2 minus x1. Okay? Lots of ways to write it. These are the ways that you're familiar with. Consider the two functions, f of x equals 5x plus 7 and g of x equals 2x squared plus 1. Calculate the average rate change for both functions over the intervals. Do your work carefully and show the calculations that lead to your answers. So there is f of 2 and f of 3. Now I'm going to do g of 2 and g of negative 2 and g of 3. I changed my mind. First of all, I'm going to do delta y over delta x. Delta y over delta x. So we have y2 minus y1. 22 minus negative 3 is 25. Then we do x2, then we see the 22 matches up with the 3. The negative 3 matches up with the negative 2. That equals 5. Okay, now let's do the same thing for the quadratic. There they are. Now let's do delta y over delta x. The average rate of change, the slope between 2 points. 3 minus negative 2 over 19 minus 9. 5 over 10, which is 1/2. Again, it's extremely important when we do these. The 12 matches up with the 1. The 12 matches up with the 1. The 32 matches up with the 5. The 32 matches up with the 5. Extremely important you do that. It's extremely important that the 51 matches up with the 5. 51, sorry, there it is, matches up with the 5. 51 matches up with the 5. The 3 matches up with the 1. The 5 and the 1, that's a little bit better. Just gotta always check. The 5 matches with the 1. The 5 and the 1, 51 and the 3. So is there something strange here where we have the average rate of change being 1/2 and the average rate of change being 12? Is there something going on here? What is going on? The average rate of change for F was the same between them, but not for G. Uh-oh. I take back that uh-oh. Here we have 5 and 5. These are the F's. So we have the same rate of change, 5 and 5. Why is the 1/2 not the same as 12, is what it's saying down here. Well, what kind of equation? F is a linear equation, it's a line. G is a quadratic, it's a parabola. So what happens with a parabola? It curves, its rate of change is negative, 0, then positive, while a line, it's constant, either always positive or always negative. Write down something here. I just gave you a couple of reasons. Write down your own reasons. I'm not going to. The table below represents a linear function. That means the rate of change is always constant. So let's find the rate of change. Delta y over delta x. Let's just do +1 minus -5 over, let me see, I did the +1, so now I got to do the 5 minus 1. 6 over 4. Now that we know what the rate of change is, how are we going to find out this? I said earlier that another word for rate of change is slope. Y equals 1.5x, okay, plus some number. For every x, for every 1x, y goes up by 1.5. So there we see a 6x, so y goes up by 6 times 1.5, which is 9. Y goes up by 9, that's a 10. Goes up by 12, so I'm going to do 12 divided by 1.5, and that's 8, so that's go up by 8, which is 19. That goes up by 26. 26. So that means that we multiply by 1.5. We had 39. Whew, that was some thinking, especially on a day like today. That's it. If you have any questions, make sure you ask me in class. And I mean ask me in class, because my brain isn't solidified today. Catch you later.